Welcome to Tejas Statistics. In this class, we are going to learn about the mathematical or classical definition of the probability. The uh, If the random experiment has n small n possible outcomes, which are exhaustive, mutually exclusive, or and equally likely uh, events, and m of them are the favorable to an event e, then the probability of an event is given by probability of E is equals to the favorable number of outcomes divided by the exhaustive number of outcomes. That means the total number of outcomes. The probability of E is equals to m divided by n. Note, the number of outcomes are favorable to the event. That means m cannot be greater than the total number of exhaustive outcomes, because the probability is always lies between 0 to 1, the certainty condition of the probability. So 0 less than or equals to m less than or equals to n. Very important. Next, in examination they are asking write the limitations of mathematical or classical definition or the demerits. uh, in this we have some limitations for the classical definition. If the various outcomes of the random experiment are not equally likely or equally probable, if the exhaustive number of outcomes n, the number of the experiment is infinite sometimes or unknown. Okay, if it deals only with the discrete variables, only with the discrete variables it is going to deal. So these are all the demerits of this. Next, coming to the merits, it is the simplest and easiest way to compute the probability. It can be used in statistical mechanics or statistical machines. Okay, uh, it offers prior probabilities that can be reflect ignorance, which are oftenly considered to be suitable before conducting an experiment. So for that reasons we are going to learn about the another definition, that is called statistical or empirical definition of the probability. Let the random variable the random experiment be repeated a number of times under similar conditions, that is, let n trials of a random experiment be made where n is very large and event e occurs m times in the n trials. So then the probability of e is given by probability of e is equals to limit as n tends to infinity m divided by n. 0 less than or equals to m by n less than or equals to 1. So here we can see that some different definition of the probability, that is a statistical or empirical definition of the probability. So here limit as n tends to infinity m divided by n, this is very important. Okay, that experiment is repeated unknown number of times, that is infinity times. So but the probability is always approaches to the values of 0 and 1, it lies between. This approach of probability can be the merits used even in case of trials that are infinitely large. It does not require all the elementary events to be equally likely. Yes, we have some demerits also. It cannot be determined uh, except the probability of an event. Okay, sorry, it cannot be determined the exact probability of an event. Exactly, it is not going to be tell. Next, it does not provides any guarantee for the existence of the limit. Okay, limit of relative frequencies. Okay, there is no existence of the limit. Okay, so similarly we have some more definitions. They are the probability space, the triplet we can call it as SBP. Okay, it's a sample space, and the base values are that is sigma. Field is a set of all subsets of S. Next, the P, the probability function defined on, okay, the sigma field. Okay, that is, it is either continuous for all the events. You can see these are the triplet. Yes. Next, just see some problems over here. uh, First question, two dice are thrown. Find the probability that, what we can say here. First one, both the dice are having the same number. First question, what is the probability of getting that? Next, the second, the first dice throw or shows the number 6. Next, the sum of two dice is 8. The sum of two dice is greater than 8. The sum of two dice is 13. And the sum of the numbers on the dice is any number from 2 to 12. Yes. Here you can see the solutions of the first one. In a random throw of two dice, the total number of possible outcomes are the cases, that is 6 square, that is 36. Sample space you can see over here. Yes, in first question what they asked, the even, that is we are letting it as even. Both dices are shows the same number. So what is the sample space or the favorable events for this? So that is 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, and 6 comma 6. The total number of cases are 6 divided by 36, that is 1 divided by 6 is the first question solution. Next, the first die shows the number 6. The first die shows the number 6. What is this? Okay, how many favorable events are getting? So in that question we have the 6 cases. The first dice should contain the 6 number, and the second dice may have any another number. That is, how many cases are existed? 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, 6 comma 5, and 6 comma 6. Total number of cases are 6. We are letting it as E2, the second event. Next, what is the third event? This getting the sum of two dice is 8. So how many number of cases are going to be existed? Let's see. From starting onwards, if I add 1 comma 6, I may get the 7 only. Okay, if I add 2 comma 6, I may get 8. Yes, so that is what I need. Next, 3 comma 5 is the second case, 4 comma 4, 5 comma 3, and 6 comma 2 again. How many number of cases are there? 5. 5 divided by 36 is our probability. Next, coming to that fourth event, the sum of two dice is greater than 8. Yeah, that is greater than 8 in the sense you may get 9, 10, 11, 12. Okay. Yes, 9. 4 plus 5. 5 plus 4. 6 comma 3. 3 comma 6. 6 comma 6. And 5 comma 5. 6 comma 4. 4 comma 6. 5 comma 6. And 6 comma 5. How many number of cases are there? 10. 10 divided by 36. That is 5 divided by 18. Next. The sum of two dice is 13. Yeah, this is an impossible event. 6 plus 6 is 12 only. Okay, if the first dice shows 6, the second dice is also shows 6. If I add them, I may get exactly the value of 12. It is not equals to the 13. So we won't get the sum of the number on the dice is 13. So that is 0 probability. That is 0 divided by the 36. So that means is a 0. Next, the sixth last one, that is a sum of the numbers on the dice is any number from 2 to 12. So that is 2 to 12, 1 comma 1, 1 plus 1 2, and 6 comma 6. So that is 6 comma 6 is nothing but 12. Okay, so we will get all the numbers. So that is the sample space of the favorable events are 36. 36 divided by 36 is the probability it is an sure event, that is 1. Okay, like that you had to calculate all the probabilities for the given question. Next, see some more question. Find the probability that a leap year is selected at random will contain 53 Sundays. So very important, 53 Sundays in the leap year. So what is a leap year, by the way? How many days it is going to be consist? So that is, it is going to be consisted 366 days. So 52 into 7 weeks and plus 2 days. So that is how many days? Sundays, or in that 2 extra days. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and Sunday, Monday. There are only 2 possible cases. 2 divided by 7 is our answer. Okay, this is how the probability and its calculation. Okay, we'll see some more problems in the next session, and with some definitions also and some proofs also. Is it okay? Thank you.